Good evening, everyone. Please, can I be heard? Can I be heard? A thumbs up, a reaction to show that I can be heard. I guess I can be heard then. Hello. Okay. Let's give the rest about 2 minutes to 2 to 3 minutes to join. Then we can begin the class. There are only three in the class. I don't think it is ideal. Unless you want us to continue anyway. Okay, let's start. What we are here to do today. We have waited for them enough, but it looks like the number has not increased. Even though I'm seeing people waiting in the lobby to be admitted, I I have no power to be admitting people at the moment. So let's begin with our class for today. Give me a moment. Let me contact somebody to join the class. You can also reach out to people if you can hear me. Okay, so let's begin. Yeah, as you can see, this call has been on for quite some time. I'll be waiting for people. So let's begin. Okay, so today I'm going to share my screen. We are going to focus on um, declaring variables, and then also we are going to look at what objects are. We are going to look at what an object class is as well. We're going to look at what an object class is as well. So let's quickly dive in since we don't have much time. Today I'm very, very tired. Okay, frankly speaking, it's been a long day, and I will not keep you guys up here too long. So let's begin. Okay, so we are going to start with variables. And before I begin, I don't know, but I've been asking questions through, even starting from the lesson. I asked if I can be heard, and all nobody responded. I don't know what the problem is. Is it because of network or what? Because if I don't get that feedback, I might feel like I'm talking to myself. Okay, so I also assume that my screen can also be seen. So let's go into what I'm here to teach today. You can stop me at any point in time if you have a question to ask. Now, when it comes to um, Java, we are going to learn about variables. Okay, today our main focus is going to be on variables. Okay, if there is a need for us to pick up certain information from the slides, we are going to do that as well. But for now, let's focus on what a variable is and what it does as well, how to declare a variable, and so on and so forth. So I hope my screen can be seen and the tests are bold enough. If not, kindly prompt me so that I can see how best I can enlarge the test for us to see. Okay. Okay, now what is a variable? Variables are fundamental building blocks in our programming language and most programming languages as well. And why are they fundamental? Okay, let's continue. I thought Mr. Boaji had a question to ask.
Yes, sorry about that. I wanted to ask before we even begin, is it possible we'll get our hands on your slides?
Is it possible that what?
We get your slides.
My slides. Oh, sure. I will send them to Joshua. Joshua will forward them to you. Yep. I hope
All
that will
right,
be
thank
okay.
you.
All right.
That'll be fine, thank you.
Okay, so let's look at what variables are. And we have done this thing in C++. It's literally the same thing in C++. We won't waste much time. Unless you have never joined us for our C++. Show by hand if you've never joined us for any of our C++ classes before. We have three submissions here. Okay, so three of us here have never joined the C++. So that means that there is a need for me to still spend some time on it to explain what variables are, how they are declared, and why they are being declared. Okay, so we'll read through the slides with me as I try to explain. Okay. I will not spend much time on it, but you can stop me if you don't understand anything. So what are variables? So they say think of variables as labeled, okay, labeled boxes. And we all agree to the fact that if I'm supposed to store certain things in a box, okay, for if all the boxes are of the same size, of the same color, and of the same so should I say structure or whatever. But if they are all looking the same, and you know that at the end of the day, when I put something in a box, I will cover it up. So if I should stack them up on each other, okay, if I should put something in the first box, stack the second box on top of it, and put something in the other, like about five boxes, to be able to specifically tell what is in each and any one of those boxes at any given time, I have to label the boxes. Okay, I have to label that, okay, this boxes is for please hold on for me. It's an emergency. All right. So sorry for that. That was an emergency. Okay, so in general terms, okay, when I stack up these boxes one upon each other like that in that manner, to be able to tell what is found in these boxes at any given time, I have to label the boxes because I've closed each and every one of them. And we all know there are no magicians to know to have Superman to have X-ray visions or whatever. So therefore, I have to label the boxes. So I see that these boxes are for maybe storybooks. These ones are for shoes. These ones are for this. When I label them, okay, and I the label the name describes what is supposed to be inside, okay, and if the name is describing what's supposed to be inside and you open it and you see something else inside, it won't kind of like make sense. Okay, so if you see a box with books written on it, okay, and then or maybe creative art books written on it and then you open it and there are RMA books inside, it will make sense to you. Do you understand? You feel like everything has been disorganized. So there are some things that we have to know about variables. Variable comes with two things, and both of them have been grouped into one name called variable declaration. Are you okay? When I declare a variable, okay, I am saying that first of all, I have given it what type of item is supposed to be inside the variable, or in other words, the box. Okay, if I say I'm calling out a box is like a memory space in your computer. It's like you're allocating a memory space in a computer, creating a box. When you create a box, you have to label the box for us to know what you are keeping inside the box. Are you okay? So therefore, a variable in its own sense is trying to say that this is a box I have created, or this is a memory space I have created. I have labeled it, I've given it an identity. So variables, naming variables is also known as what? Identifying them, identifiers. Okay, we will learn them. So I've given the variable an identity that this variable is called shoes, okay, or pairs of shoes, and as descriptive as possible. Okay, then what I'm trying to say is that this memory space I've created, put pairs of shoes inside. Don't put anything else inside apart from pairs of shoes. Are you okay? So variable declaration comes in two folds. Okay, we are supposed to first declare the data type we are keeping inside that memory. Okay, and then name the box. Okay, so we have to name the box so that we know that okay, this box is keeping the age of a person. This box is keeping the names of people, the courses of people. And likewise, we are supposed to tell us, okay, or tell the computer that because it's names, numbers don't exist in human names except from the third and the fourth. Even that one, they are written with Roman numerals, which are letters. Are you okay? So therefore, this and you're not going to perform any computation with names of people. So therefore, it should hold this data type as a string. Okay, so we are going to also look at the various data types and the type and then what they are supposed to be holding. Any question at this point in time before I go on? Those who never joined.
Please, if you are speaking, you are muted.
Yeah, I've been speaking for some time now. Okay, mercy. Okay, let's continue. Let's continue. Sorry about that. Let me go back again to what I was saying. I was saying that, okay, think of variables as it's written here. I was just reading what is written here and I was explaining as I was reading. Think of variables as a box where you can store a piece of information, just as you might label a box books and keep inside books, okay, whether a novel or whatever is books. So you
So
keep
we
inside.
we we got that part. We go to where you asked the question if we had a question. So that's
Oh, okay. So that means that we all understand variables now from wherever we have. So now variable declaration and initialization. When you declare a variable, you can decide to initialize it by giving it a value based on the data type you have assigned to it, okay, or just leave it blank. Are you okay? So if you don't give it a value, you have not initialized it, but if you give it a value, we term it as initialization. So when I declare a variable, what goes into declaring a variable? There are two things that goes into declaring a variable. One, providing the data type, and two, naming the box. Okay, so you can say the data type has been provided here, and then the name of the memory space for easy identification and for us to call upon this memory space as of when we need it later on in our code. So we call it an identifier. Okay, when you give birth to a baby, you name the baby, you are giving the baby an identity. You understand? So this is called an identifier. And then kind of like what isn't like the gender of the babies, like whether a male or a female. You understand? So if you are giving the person a male's name and it's a female, those kind of like causes this kind of confusions. And so the system requires that when you're declaring a variable, the data type must go with the type of data you'll be keeping inside that container named my numbers. So if you should name something like my numbers and give it a data type of integers, which we are going to look at the data types right after this. Okay, you can see data types here. Okay, then it should hold figures, okay, not letters, okay, because integers take figures or numbers, okay, that are whole numbers. Let me be specific: positive or negative whole numbers. Now initialization comes with giving the declared variable an initial value. Okay, you give it an initial value, which because it's a variable, the reason why they call it a variable is because its data and its content can be changed at any point in time. So that's the meaning of the word variable. It changes, it can vary. Okay, so when we declare a variable memory space, we are saying that whatever we are keeping inside of it at the moment can change as we go on with our programming. Okay, so combining both, you can see that the variable has been declared, and I said two things goes into declaring. First, telling the computer or the program what data type it is, and then giving it a descriptive name. This is what we mean by declaring. This side or this side is called declaring a variable. And when the equal to comes inside, okay, then we are assigning a value to the container. We are putting something in the container that is known as initialization. I'll ask a question about this in our, I'll get into the end of our lesson. Now let's look at some of the rules that comes in naming variables. Okay, what are some of the rules that comes in naming a variable? And just as in C++, in Java, okay, we also name variables using something called camel casing. Okay, this is camel case, and the way camel case has been written here is exactly what I'm talking about. Okay, that is making the the initial letter of the first word, okay, a small letter, and then any other word you add, any subsequent word you add to it, okay, the first letter should be capitalized. That's what we mean by camel casing. Okay, so if you look here, you see that the first C here is a small letter, but the second C here for the word case is a capital letter. And because this one will definitely end with a small letter, the first letter of the next word you add onto it, okay, beginning with a capital letter will make it easy for you to read, because now there will be a difference in each word as it is typed alongside each other. Do you understand? Because of camel casing. Are you okay? Okay, now let's look at the various types of data, what we call as data types in JavaScript. Are you okay? Okay, so now what? Let's look at the data types. Now we have two data types in JavaScript. Okay, we have two data types in JavaScript. The first data type I would like to talk about is what we call as the primitive data type. Okay, the primitive data type. Okay, this primitive data type, okay, is just simply trying to say that these are data types that holds a value, okay, or an object inside this container, and whenever they are called upon or they are used, it is the object inside the container that is called upon and used. Okay, and I will explain it. And we have the reference data type. Okay, it also has its own explanation. So let's look at some of the data types that falls under primitive data type. We have bytes for 8-bit integers, that is from 100 and negative 128 to positive 127. These are the numbers that can exist inside bytes, and they must be integers. Okay, and we know what an integer is: a positive or a negative whole number. That means that there shouldn't be a decimal or a float in its natural sense. Then short, which I normally like using, okay, should hold a range of integers from negative 32,768 to 32,767. So these are the sets of what numbers that can exist when you call upon a data type short. So anything out of this range causes some kind of conflation. There will be the program will have to find a way of bringing this number down, and we will learn about that as well. Then integer, which is also commonly used, okay, is a 32-bit integer, okay, and it's mostly used for storing very, 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 very um um let me say, should I say very, let me just say numbers that are logically used in our basic life. Okay, numbers that are logically used in our basic life. There are some numbers, there's no way we are going to compute them. Won't find it. But because you look at programs whereby millions of people are using that software, and then computations are going to be done maybe in a cumulative manner, maybe numbers can end up being very big. Okay, especially for companies like banks, okay, and investment companies. Some figures can end up being very big. So therefore, it is important that we, even though this is commonly used, we have to also look at other things that are way bigger than it. And that is what we mean by the long. When you are using long, you are using a 64-bit integer. This is a these are used for storing very huge numbers, talking about billions here. Are you okay? Now, longs, okay, I didn't add it to this, but longs also require a suffix at the end of the number you write, L, okay, which we normally use capital L, because sometimes when you use when you write a certain number, okay, it might look like an L. It may look like an L. So if you add a small L, it kind of like causes that confliction, especially one. Okay. So therefore we use capital L and this one to capital F. Okay. I should have said that, but it's not really much of a rule depending on the capitalization of it. You can choose to use small letter though. But just to make your code more readable, we normally use capital letters. Then float. Okay. Float. Now, why nobody asked me why do we put L for long, but we didn't put I for integer, S for short, and all. Okay, so the computer, the program, let me say the IDE environment, okay, accepts any positive or negative whole number automatically as an integer. Okay, so there's no need for you to end your number with an I, okay, because the machine, why do I keep on saying machine? The system accepts any positive or negative whole number you input as an integer. But for long, okay, you have to explicitly say that this is a very huge number, so treat it as such. Do you understand? And the same goes for float and double. The system accepts every single decimal value you input, okay, as a by default a decimal number. As you can see, default for decimal numbers. Okay, so that's the default data type for decimal numbers, double. Okay, but if you want the machine to treat it as a float, that is smaller than a double can be, okay, then you have to include an F at the end of your initialization. Boolean logically stores true or false values. This is nothing much to talk about. And then characters, we all know that it can only store one input, one letter input, whether a letter, a number, or a symbol. My emphasis is on a symbol. Are you okay? A letter, a number. Are you okay? And whatever is stored inside when initializing should be done with the single quotation mark, not the double. Double is for string. And we can realize that we don't see string here. I think it's obvious that we don't see string here. There is a reason why. So then let's look at the reference data types. Are you okay? And before I go on, any question on the primitive data types? Any question? Is concerned, let's proceed. No question. Now, the reference data type, as its name says, unlike the primitive data type, the reference data types don't store values directly. I repeat, they do not store values directly. What they do is that they store the address. If you look at the little man's computer, let me try and see if I can use that to create a basic explanation. Yeah, little man's computer. You can open it alongside my presentation, and as I try to explain. Sorry, I think I have to type it. Yeah. Okay. So with this interface, we know that these things here are called memory addresses. Memory address, the 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and so on and so forth. So when we are talking about reference data type, okay, it does not store the contents of the in the memory, but it rather stores the memory address. Think of it like an address of a house. Okay, think of it like an address of a house. If I provide you with that address, and then I provide somebody else to with that same address, if you should follow the address correct, you all end up at the same house. That is at the content, okay, of that address. But if I should change item in the address. It does not change the address. Understand the fact that and then I can also give another example as the BAM library. Okay, those who wrote exams in the BAM library or a library. Whereas when you get to a certain point where they have to take your bag and store it, okay, every store, should I say case, has a number. Are you okay? And that is the address. So if you should go to that um keys, okay, with your key and open it up, there is something that you are placed inside, and that's what you're expecting to see. That's what I mean by reference data types. Whenever I reference something, okay, it just looks at the address and looks at what is inside the address, okay, and then brings it out for me, but it does not store the contents of the address. Do you understand what I'm trying to say? Okay, it does not store the contents of the address. It just look at what is in the address and brings it out to me. That is all. That's what I mean by referencing. Okay. Okay. Any question? All right. No question. Then let's proceed. So we are going to look at these two things, but before we look at them, let's quickly practice what we have learned in our IDEs. I don't know if it's Intelli. I installed a new Windows. Okay, so I installed the apps, but I didn't. Oh, I've not opened it to do certain things inside. So it might look like as if I've not been using it. I recently installed a new Windows, so I had to reinstall all these things again. So yeah, as I stated earlier, so you can see it's like as if I'm now agreeing to certain terms and conditions. So you can open yours if yours is already set up. Okay, so I'm going to create a new project. Okay, I'm going to create a new project and title it my first Java. Okay, all right. Dot Java as usual. Okay, please give me a moment. Yeah, things are now coming together. Forgive me. Okay, yeah, things are now coming together. I will link my account later. For now, let's just focus on what is here. I will be clearing away certain things, and I think in our previous meeting, I explained each and every line of code here and what they mean. I didn't just say that that's what I explained each and every word here and what it means. So I'm not going to go back and then explain all this. Okay, if you didn't get it, you can watch the video again from the links that will be provided, and then you take note of that. Okay, you take note of certain things. Okay, let me try. I'm trying to clear away certain things from here since I will not be needing them. I don't need none of these guys here. I don't need any of them. This guy is closing as this guy is opening. Where are you? Okay. Don't need this one. I don't think I need. Okay, this one's closing is that. Okay, this one that I don't need. Okay, so let's quickly practice variable declaration and data types and all here. Okay, so I'm about to type. If you don't understand anything, you can let me know. So if I am to store certain things in memory, okay, the first thing I have to do is that I have to declare a variable. Okay, and let's make it practical as much as possible. So let's take a scenario. I want to store data about somebody, okay, probably in this class. Let me just pick somebody in this class. I don't know if Joshua Anand is here. Yeah, 100%. So Joshua, you mute your mic and provide me with some information as I'm about to type. Okay. So Joshua, I want to store first of all your age, your name. Sorry, your name. So Joshua, upon declaring the variable,
Yeah.
okay, we are working hand in hand here. Okay, so I want to store your name in a variable in a box. Okay, so what is the data type I'm going to be using to store your name?
String.
A string. Why? You care to explain to us why?
Because they are single characters.
Single characters. Do we agree? No. Or do we? What are you saying here? 978.
Please, am I correct?
No,
That's sure.
that's sure, Kakra. But you can redeem yourself, or somebody can redeem you. Why should we use string to store an individual's name? If it's a single character, I'll be using char for character. But we are using string because
Because
Because you
you're
are
using
storing.
series of characters.
we are using series of characters. Very good. So string stores series of characters. Are you okay? So therefore, if I'm declaring a data type, what are the two things that goes? We are agreeing practically. What are the two things that goes into declaring a data type? Not initializing, declaring. Who can answer? So we can use it to type our code. You have been in my sections so many times, and you know that like we are interactive. Nobody will laugh at you. Probably somebody will show a laughing emoji, but unmute and speak. So we are having a discussion. So just unmute and speak. Calvin, Bafo.
Please, I wanted to ask, why didn't you bring the public class name on the top of?
Public
Why didn't you
public class.
bring before the public static void?
Oh yeah. Thank you for drawing our attention to it. Sorry. Um yeah. This is it. I mistakenly deleted it. Sorry. Forgive me. Mercy. Deleting an name. I was deleting a whole lot of things. I think I have to delete this one too. It's not necessary. I don't really need it. Okay. Thank you very much for drawing our attention to it. All right. So we settled on the fact that the data type I should be using is string. Okay. The data type I'm to be using is string. Okay. And I said what goes into declaring a data type? What goes into declaring a data type?
Whether or not we'll be using it for arithmetic purposes in the future.
No, I said when we are talking about declaring declaring a variable, what goes into declaring a variable? I think I didn't ask the question well. What goes into declaring a variable? Okay. Oh, please unmute. Unmute and speak. If you know the answer, unmute and speak.
I think the data type.
Okay, so let's go back to our presentation. When I was present, hey, where is it going to? Okay, it was a PowerPoint. Okay, we said that when it comes to declaring a data type, there are two things that are involved with the declaration of data types. First of all, we need the data, declaring of variable, sorry. We need the data type, and then we need to give it an identifier. Are you okay? When you're creating a box, you tell the computer what is the nature of item you are putting in the box, and then give it a name for easy identification. That's why it is called an identifier. That's what goes into initial what do you call it, declaring a data type. So now that we have told the nature of item or data we are storing inside by declaring the data type, the next thing we have to do is to give it an identifier. Are you okay? So in this sense, we have to give it name, since we are going to use a name of a person. And then after here, since we know the person we are going um to we know him by name already, so we are just going to type his name here. Sorry about that. We are going to type his name here. Okay, but let's make this a bit more interesting. Let's do this way. You can stop me if you don't understand why I'm doing it this way. So let's just do this. Okay. Sorry, I didn't do my camel casing right. This is how camel casing is supposed to be for easy reading. Are you okay? So terminate. As usual, terminate every line of code when you are done with it. Are you okay? So first name, then I can go again and say string. There's a much simpler way to type this though, but sorry. I can go again and say string, then I'll say last name. How do I like typing capital letters like that? Last name. Oh, okay, cool. Last name. Then now I am initialize it with Anan. Is it double N? Double Anan.
Yeah, double N.
Okay. So double N like this. Okay, then I terminate it as usual. I okay. Now we have declared data type, and then we have initialized it as well. We have done two things just now. We've declared a data type, and we have this is the declaration aspect, and this is the initialization aspect. Nevertheless, I can decide to go about without initializing it. Are you okay? So when I should display, okay, see out, when I should display this thing out on the console, that I should display first name. Okay, I should display the first name. If I'm supposed to display first name, sorry, that is a, I'm today.
If you declare it
So
like that, nothing will pop up.
listen, they said variable first name might
Might
not
not
have been
enjoy.
initialized. Variable first name is never assigned. Variable first name is never used. So you get to understand the fact that, look at that, because nothing is going to pop up because I've not placed anything inside it yet. What term did they use for me not putting anything inside it? Initialization. Do you understand what I'm trying to say? So if I'm asking the system to see out, or how am I saying see out? System out, print line something, okay, and then the container, and then you go into the container, you don't find anything there. What should the system bring out to me? I hope you get the logic behind it, right? So therefore, if I want the system to, hey, what have I done? If I want the system to actually show me something out of this container, okay, then I think the best thing I have to do is to initialize it. Okay, I should give it an initial value. Okay, then I can see something out of it. Are you okay? Do we agree to that? So you can see that we don't really have any error. And when I see it out, okay, because it has been initialized, when I should see it out, it's building the code. Okay, when I should see it out, did I install JDK? Yeah, I think I did. Okay, so we can say the name has been shown out to the console as what? As Joshua. You can see they have highlighted it here. Okay, so that is from the main class. You can see here that it also shows what class this information is being displayed from. The main class. Are you okay? So likewise, if I should also see out what should I see out? Last name. Okay, if I should also see out the last name, sorry. I have to concatenate it, sorry. I have to concatenate it with a plus sign. But I should see out the last name as well. Okay, we are going to see that both now we have Joshua and Anan being displayed on the console. Okay, so I'm asking the system to see out Joshua, the first name, and then provide it with what? Now who can explain to me why this name is together like that, but there is no space between them? And in C++, I explained that when a code is being run, it ignores empty spaces in the coding environment area. So it means that this empty space has been ignored, and this empty space after the plus sign here, the space I created, and likewise here too, has also been what? Ignored. This side would have I've been able to highlight it. It has been what? Ignored. Okay, so the system now puts everything together as one. But what are some of the ways we can correct this? Okay, I can say that I want to see this guy, okay, this space before I add the end result to this guy. So this is what happens. The system first displays first name, displays an empty space because I've got a string, okay. So that string is going to be displayed. The content of that string is going to be displayed, and it's just going to be an empty space being displayed before it displays the last name. So if I should run this thing again, okay, if I should run this thing again, you're going to see that after building and all, okay, Joshua has a space between his first name and the last name, okay, because of what I have done here. You understand? Now, in coding as well, you can put how do I say this? Okay, that is when they are all being assigned the same initialization, or they are all having the same initialization. I can put first name right beside with a comma like this. Okay, then I'll put last name like that there like that. Okay, if I'm giving all of them the same initialization, I can do that as well. Do you understand? So there's no need for me to type this if at the end of the day they are all going to be having the same thing. So if I should run this code, you see that it will come out as Joshua space Joshua. Okay, because first name and last name, oh sorry, they said variable first name must have been initial. Where are we? Oh, sorry. My bad. My bad. My bad. I think this is how it's done. No, it's not this. Hey, why am I missing C++ and everything together like that? Forgive me, okay. First name, last name. I'm missing C++, and sometimes these codes they confuse me though. You can use listing. You can list them to initialize it as one. That's what I know. Okay, but I don't know why it's not working at the moment. Anyway, I'll find out. I'll go and do a bit of my homework again and then come back to this. Okay. But it can be done. If, for instance, we have X, Y, Z all having the same value, I can list them, okay, and then assign a single value to them so that wherever X, Y, and Z is displayed, okay, the assigned value will also be displayed for. It's called upon, the assigned value will be called for them as well. Okay, so this is what I mean by declaring a variable and initializing a variable. Okay, now let's come to the reference type. Okay, so that I can name this guy. How should I name this guy? Um, I should name it a variable declaration. Variable declaration. declaration and initialize initialization. Okay, I think this is correct. So variable declaration and initialization, and I'll give this one primitive. Okay, primitive. All right, primitive. Now let's come to variable declaration and initialization with the reference. Okay, let's come to the reference. Reference. Oh, why am I typing everything in caps? Oh, Kwaku, forgive me. Typing skills now. Reference. Okay, so I think this is better now. Now let's look at the referencing part as well. Okay, if we get the understanding of this very well, we'll be fine. Most of our code, this is one of the most fundamental things to understand when you're using variable declarations. If you don't know how to declare variables and all. So now let's look at reference data type. We say unlike primitives, okay, this does not store the value directly. They store a reference or memory address to the object. Example include string arrays. You didn't just say string, but they say string arrays. They are different things. And any class you create or use, okay, like scanner and array list. Now let's look at oh, they didn't give us an example here. Just went to typecasting, variable scope. Okay, let me just get an example from our best friend. We all use it most of the time. So let me just get an example here. Just to explain. So reference. Referencing. Java. Referencing in Java. Don't mind the way I wrote it. Don't mind. Okay, so referencing in Java. So we are going to create string. Then we are going to say string is equal to A. Okay, string A is equal to hello, and then B is equal to A. B reference the same object as A, and we will explain that. Okay, let me make it more complex because this is more basic. I want more complex. Complex is good. So we can break it down. When I say complex, I didn't say this one. Let's see. Let me say like array. Okay, I want to use array to explain this. All right. Now we have some array here. Okay, we have some array here to use. Now we are saying that to use referencing specifically arrays, okay, we first declare the data type int, okay. Then what we do is that we use this bracket here beside it. This tells the system that what we are about to list is an array, okay. It's an array, a set of something stored in a memory, okay, in a particular memory address. That's what I mean by array. So it is always numbered from memory box 0, 1, 2, 3 in that order, as just like how we saw in a little man's computer environment, stimulator environment. Okay, so we are going to see that now. They said that now we now give it the identifier. So we create the data type, okay, like this, and then we give it an identifier. Then we say that new list, new int 5. Oh, this one is okay. This one is better. This one. So we have a set of values stored in the variable container identified as A. 1, 2, 3. Okay. Then we are saying that B variable B should be equal to A. Now this one is much better. Let me just copy this into the coding. Why am I doing this? Let me just copy it like this. Okay, so let me just paste this here. Then I'll use this one to explain. Let's see what have I done. Okay, so now we are just saying that, okay, this is how to declare for when you're doing referencing for arrays. Okay, for arrays. It's not for any other thing, just for arrays. So for arrays, you declare the data type by saying int, then you continue it with this one. Okay, letting the system know that you're about to assign some kind of data into some memory addresses. Okay, now then we say that we give it an identifier A. You can make it any other thing that you want. Okay, that it should be descriptive as possible. So let me just say this one. Let me call them positions. Let me say class. Okay, class positions. So that will be the first, the second, and the third. Okay, respectively. So class positions. Are you okay? And I said that 1, 2, 3 are the class positions are placed inside the memory addresses. Now the first position is going into memory address 0. The second position is going to memory address 1, and the third position is going to memory address 2. Please take note of that. The first position is going into memory address 0. Second position is going to memory address 1, and third is going to memory address 2. We start inputting these data in the memory addresses. The memory address has been numbered from 0. We should take note of that. Okay, so that is why I'm saying this. Then I said that let B, okay, be equal to this class positions. And I'm about to specifically say that B, let me come in. Now I'm saying that let B be equals. Maybe I'll meet you. Okay, let's just go with A, B, and C. Now let B be equal to A. I'm saying that whatever is, and you can see that when I was declaring the B, okay, I also use the array type of what data type declaration as int, and then I use this trying to tell me that both B and B are arrays, okay, holding a set of values assigned to memory addresses. Are you okay? Then I said display. I said B0 is equal to 99. For now, we are saying that let's print out B0. It will print out 99. Why is it printing 99 when what has been stored inside here is 1? Let me just run it for you to understand. You see it on the console so that you understand. Okay. And you can see the 99 here. You can see the 99 here. Why? Okay, somebody had a hand up. I think I just came here and I saw that. I thought it was Calvin. Oh, Calvin, yeah, okay. Okay. So I'm saying that why is it that the console is printing out 99 when what if I said B is supposed to be A, then it means that the same memory addresses that B is using should be assigned to A with its contents being 1, 2, and 3. But I said B0 is equal to what? 99. But if I should come here and print out A0, I'm seeing 99. Why? Because I am saying that the memory address 0 for A should store 1 inside that container. Then I said that let B be the same as A. They should have the same memory addresses. Then I looked at what is in A memory address 0, which is storing 1. And then I said, let it now hold the value 99. So that means that what is here has been taken away. When I went to that address and I saw 1 inside that address 0, okay, it has been taken away. And what has been replaced with it? 99. Now, why? Oh, okay. 99. Then when I printed A out, look, I printed A, address 0 out. What is stored in memory address 0 out? That is it. Let me just create some spaces here so that you will see it clearly. Okay, when I said go into the memory location A, the variable A, memory box A, and then find its memory address 0 and see what has been stored there. It's no longer storing 1. It is now storing 99 because I have referenced. Let's see. This here has made this complex, but it's a very easy thing. I'm looking for a very, very easy example. No, this one is still the same thing. Original shadow, same referencing. I think I have to type one myself. Let me just type one myself. Okay. Let me clear all this side because I'll still have to use A. Let me type it myself. Real quick. Let's not waste time. Okay. Now, let's make this more practical. So class, as I use as first, class positions. Okay, that is for this, and then I declare another variable and say that, let's say Joshua's position or Joshua position. Joshua position. And then I say that let Joshua position be equal to, let Joshua's position be equal to class position. Class position, memory address. This is it. This is where you. Okay, there you are. Sorry, we put this one here. Right? Oh. Okay, now let me print out Joshua's position. Okay, let me just print out Joshua's position. Print out Joshua's position. Okay, so when I print it, let me just build it up and print it out. Then I'll use it to explain. Hurry up, hurry up. Good. Now, why is it that I said, look at this. I said, this is referencing. So in the class positions, I created memory boxes. Okay. And then I said, first memory box is 0, 0, and it should hold the position first. Second memory box is 0, 1. It should hold the position second. And third memory box is what? 0, 2, and it should hold the position third. Then I said Joshua's position in that class, okay, is that it's supposed to be referencing the class positions, and it's supposed to go into those memory and pick what is in the memory address 1. What is stored in who can tell me what is stored in memory address 1 for class positions? I'm displaying it on the console, but who can tell me what is stored in memory address 1 for class positions?
2.
2, very good. So it went, it didn't look, it didn't alter, and understand the fact that now I have created a link between them. But right now I'm just referencing the first one we saw, the code that we saw before that I said is making it complex. It went to alter the content of the memory address. Are you okay? But this time around, this one is just going to that memory address, see what is there, and then bring it out for me. It is not storing it. So I will not say that I have assigned Joshua's position 1. I've assigned 1 to Joshua's position. So the memory is supposed to display to me that he is first. It just went to a particular memory address, okay, saw what has been stored in that, reference it. So I just referenced that address. It went there, saw what has been stored there inside that memory address 1, and then picked it out. And what has been stored there, the position 2. Ayo, that's standing for second. You get what I'm trying to say? That's what I mean by referencing. Please, who understand what I'm trying to say? Sorry, who don't understand what I mean? I should come again. Very good. What I'm trying to say is that. Oh, this thing is here is telling me again. Okay, it has come. I can minimize it. Okay, what I'm trying to say is that when it comes to the referencing data type, I created a whole note on this, but because of my new Windows installation, I lost everything. I don't know why I didn't back it up. What I'm trying to say is that, okay, when you declare a memory type array is a referencing data type, by the way. This is how it's declared. Then we have to identify it. We give it an identifier, a name. They write something on the box so that we can easily identify it. But because it is an array, okay, the list of values you put into it are being stored in memory addresses. So when you are going to declare any variable in relation to those memory addresses, we just reference from the memory. We don't pick what is in the memory and store it in that variable. Understand? We are just the next variable will just go to class positions, look at memory address 1 and see what has been stored there. What is stored in memory address 1? The number 2. So it just goes there and see what has been stored there and prints it out to you, but it does not store it. So I cannot say that Joshua's position is, I've assigned a value to Joshua's position as 1, like 1 as we are seeing here. But what I have done to Joshua's position, that I have told the variable Joshua's position that it should go to what class positions, look at memory address 1, okay, and see what has been stored there and display it as Joshua's position. Please, do you understand? So this guy is just Joshua's position is just referencing class positions content based on the memory address. I am asking it to go and look inside, just referencing it. Please, do you understand?
Yes, please.
Good. But with the primitive, let me use numbers for primitive. Okay, so Joshua, give me a number. Let's work with numbers now. Let's go with integers. Somebody should figure out something out for us. Age. Okay, so nobody will speak. So let me just create something on my own. So age is equal to, at least I can get a number for
10.
somebody. Okay, 10. Very good. I like that. When we come, and then I say that I give another something that will also hold. Let me say long. No, let me go with another. What other thing can be an integer? Um, Please help me out. Apart from age,
Maybe
what?
student ID.
Okay, student ID. Okay, so
Yes.
let's just take ID. Okay, so for the fact that she is the one speaking, nobody speaking, so whatever she says is fine now. So student's ID is equal to age. Please, let's understand what is going on here for primitive. For primitive, this is what is happening. This guy, okay, student's ID goes here into the container I've created and identified as age, sees what has been assigned to it, takes it and now stores it for this. It stores it for this variable ID. Do you understand what I'm trying to say? It did not go and reference by looking at what is in the memory and display it. No, this time around it picks its contents and assigns it to it. So this thing is now being assigned the same value of what? Of age. Please, who do you understand what I'm trying to say?
Yes, please.
Good. So if I should print out ID, okay, if I should print out ID, we are going to see who can guess what we are going to. Alvin, you can only just speak. We are going to see 10. Why? Because
We
why
assign 10 to
Very good. We have
Thank
taken
you.
the value as assigned to the variable container age and assigned that same value to ID. This is what I mean by primitive data type. Are you okay?
Hello,
It
please. Can
picks.
I ask a question?
Yes, please.
Please, so with the int age and the ID, so
Yes,
the
please.
reference, you mean that the the ID, the age doesn't like the ID is the new way for the age, a new container for the age, or
The ID
I
is
don't know
not no.
if you get what I'm saying.
The ID is not a new container for age. ID is just going to the container age and pick its value there and now assign it to a cell. ID is going to the container age, pick the value there and assign it to a cell. You understand? But these two things are very, very independent. That means that I can change that's one thing about primitive data types. For reference data types, they are immediately you reference something, they are linked together. So when I change what is what has been like what we saw in the other example, the memory address 0. So I can say that I can come and say that Joshua, I'll come Joshua position, okay, memory address 0. Memory address 0. Okay. Oh, why am I typing 0? Memory address 0 should now be assigned maybe 3. Understand the fact that, oh, what is happening here?
What?
It's redundant. Oh, sorry. I think I left. What did I leave redundant? Local variable age is redundant. Local variable ID is redundant. People, why is it redundant? I've assigned value. Anyway, let me just comment these guys out so that, oh, what did I do? Let me just comment these guys out. Okay. So that we can focus on what we are doing here. Later on, then I will comment it and then. Why are they asking me to type int again? When you declare memory and then you are typing, changing the value in it, you don't have to type is data type again. Anyway, since you're saying I should type it, let me type it. It has declared, it has brought about another error, and 6 of them actually. You see. Anyway, let me explain this thing this way. I'm just trying to say that these ones are interconnected. Okay, that these ones are they are connected. That's the reference. But when it comes to the primitive, okay, even though it is taking the value of what you are going to pick and assign to it, they are independent. That means that I can change the value of ID. Okay, I can change the value of ID and it will have no effect. It will have no effect on age. So I can change ID to maybe 15. It will have no effect on the age variable and what has been stored inside age. Even though initially I said that ID should hold the same value as age, when I declare ID again and I say that let the value of ID now be 15, okay, it has no effect on what has initially been stored in age 10 because they are all independent even though it can go and pick its value. So if I should run this thing right now, we are going to see that our ID is going to change to 15. It's going to display 15, not 10. You can see that it's displaying 15 now, but not 10. Even though initially I said I should go to age container, pick what is in age container and assign it to itself as its value for ID. I later on said that let ID now be 15, and it had no effect on age. So I can print out age as well. I can print out age. Now let me just change this one to age and then print it out. Okay, run the code and print it out. And you see that age is still 10. Age is still 10. You see, age is still 10. It has no change because it is totally independent of ID. It is totally independent of ID. But with this one, it is not dependent. Immediately I reference something to something and I change what is stored in the memory address of that one. It affects the original memory address. This, do you understand?
Yes, please.
So with primitive data types, okay, I'm going to take the content of a primitive data type. They are totally independent of each other. But this one, it goes and pick the value of what has been stored in the variable, not its memory address. It picks the value of what has been stored and then assigns it to itself and stores it in its container. But with the referencing, okay, it just goes to the memory address, sees what is in the memory address, and displays it as it is. It does not alter it. Please, do you understand what I'm trying to say? But if I should alter it, when I'm saying that let Joshua's position memory address Joshua's position hold like this, maybe 0 cash Bayata. Come in, please give me a moment. Let me. Somebody has their hands up, or Joshua, is there anybody's hands up?
Actually, no.
Okay. This one is some way. And I wish the slide I prepared, I didn't notice that I really did not talk about it that much. That is this one, but it's very important that we get to know this referencing differences and what it can hold and what and blah 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 and so on and so forth. The reason why it's very important is that we should understand what it means to reference from something, and we should also understand what it means to pick the contents of something. If I'm referencing a particular memory address, I'm just going into the memory address, and it's like as if I give two people the address of a house and I say they should go follow that address and go and see if their house is actually there. When the two people get to the location, they are going to see the house and then tell me that the house is there, right? Based on the address I gave them. Are you okay? It's just like the memory is it memory buffer register? It goes, it takes the contents of what has been stored in and then delivers it to the memory data register. Do you understand? It delivers it as it is. What it went there to see, that's what it picks and delivers as it is. Do you understand what I'm trying to say? So if it's an instruction, it delivers an instruction. If it is a data to it delivers a data and it sends you to the respective parts. Do you understand what I'm trying to say? So that's what I mean by the referencing. That's what I mean by referencing. So referencing just goes to that memory address, picks what is there and deliver it. But it does not assign its value, okay, to the new variable and say that, oh, when I went there and I said I saw 1 in that memory address, so therefore from now henceforth your value is 1. Please, do you understand what I'm trying to say? It just goes, picks it and displays what is there as it is. It does not assign it to it. But with the primitive, it assigns the value. It picks the value and assigns it to itself and stores it. If I should go to memory address 2, what am I expecting to see there? For here, if I'm going to memory address 2, what am I expecting to see there? Who can tell me? If I say I'm going, Joshua's position to go to class positions container, see a list of things in a memory address. Okay, just reference the memory address to and see what is there and display it out to me, or pick it as it is and bring it. What is it going to display from this data being what is displayed in memory address to? Who can guess? Because I showed you how they are numbered starting from 0. So what is displayed in memory address to? Nobody is speaking. My screen cannot be seen, or we don't know. This is wonderful. Okay, so it means
I
that
have no idea.
nobody understands what I'm teaching, right? Nobody.
No, you can't say nobody understands.
I'm asking a
We
question. Let's
understand.
buy that. But is minding me. I said Josua's position should go to class position because I look, this is not assignment. I'm not assigning. I'm just saying it should go there and reference, but it should go to memory address too. Pick what is there and then display it as it is. It shouldn't alter it, it should just display it. That's what I mean by referencing. So if I'm going to memory address 2 in class positions, what am I going to be displaying? What am I going to be seeing out? What am I
On
going to
normal
show out?
basis, addresses start with 0, right?
Yes, please. So if I'm going to class positions, okay, and I'm going to memory address 2 to pick what is there, what is going to be displayed as Joshua's
So
class
memory
position?
address 3 will be displayed.
No, the content. Look, I'm saying go into memory address 2. This is it. Go into memory address 2. What is memory
Okay.
address 2 here? This is not the memory addresses. So this is what I placed in the memory addresses, but they are being numbered from 0. So go to memory address 2 and pick what is there. What is going to be picked? That's what I'm asking.
That so is it
Three,
not the
three will be
input?
picked. Three.
Precisely. So when you go to here, this holds memory address 00. Here holds 01. Here holds
01,
02. So when you
02.
go to memory address 02, we are going to pick 3 from there and just
No, no, but
display
I
it.
told you 3. I told you 3. You said no.
Sir,
I
Fachemi.
mentioned memory address 3.
You
Like
said
I
memory
mentioned 3.
address 3. You
3.
said memory
Okay,
address
so
3. It's
so
not memory
third
address.
memory
It's
cell.
the contents in the memory address that we are looking for. And
Okay,
if
sorry,
and
sorry.
I've not even declared memory address 3 because memory address 3 should come like something like after this guy.
After
For
yeah.
you understand? So this is 00, 01, 02, 03. So if I say go into memory address 3 and pick what is there, okay, and I should run it, you see that it is going to display for us 4 as Josua's position. Do you see it? Do you see it being displayed
Yeah.
here? Do you understand?
Yeah.
So what it did is that it did not go and pick the value and store it for itself. It just went there, saw what is in the memory address and displayed it. Please do you understand the referencing?
Sure.
But for the primitive type, okay, if I should go into age, it picks the value of what has been stored in age and assigns it to itself. But my only argument is that you should take note of the fact that these two are, even though it is picking its value and assigning to itself, they are two independent variables. That means that the variable of the other can change and it will not have effect on the other one. Do you understand what I'm trying to say? And I'm assuming you.
Mm,
So that means that as I did, I changed the value of ID to 50 and I printed out what should still be shown in age and it will still show 10. Why? Because the fact that I've changed the value of ID, okay, from its assigned from assignment from 10, from what is stored in to 15, does not mean that it should change the value of age to also to 15. Do you understand? They are independent. It can go pick its value and assign it to itself, but I can also change what has been assigned to it, and it will not have effect on where it went to pick from. Do you understand what I'm trying to say?
yeah.
Please, if you don't understand, raise your hand and speak.
Oh, please go back and let me check something. I'm reading in between the quotes. So let me see something. Okay.
Yeah. So, bottom line, today has been a lot. But bottom line is that we have different types of data type. We have the primitive, and then we have the referencing. And when it comes to referencing just goes to a particular memory address, goes there and then pick its content and displays it as it is. Okay, but when I should alter the content, okay, if I should alter the content of who is going to do the picking in a particular memory, it's going to affect the content of the previous in its memory address. But with this one is dependent on each other. They depend on each other. but this one is totally independent. That means that if I should alter this guy's value from what is picking from age to 15, it's not going to have any effect on what is originally stored inside age container. Do you understand? It's not going to have any effects on it. But if I should alter this one, it's going to go to that memory address and replace. I think we saw something like that here. I don't know why I'm talking plain. Oh, okay, here's it. I like the one with the B and stuff. I saw some B00 that I copied from earlier. I pray that I find it so that we end the class with it. Good, very good. Very, very good. Excellent. Perfecto. Now let me come here and paste it for you people. Paste it beautifully here. In it. Okay. There we go. I'm saying that I've declared a reference data type as array. And I'm saying that this array data type, okay, is given an identifier A. That's the name of the variable. Then I assigned some values into memory locations 1, 2, and 3. Yes, please.
This why are you calling that one array?
That's because we have different types of data types. And I said, with the data types we have the reference and then the primitive. The array falls under primitive, and this is how we declare reference, and this is how we declare an array. Do you understand? I'm saying that the data type is int, but when I continue it with these two brackets, I'm saying that the container should hold memory addresses with values assigned into it.
Sure.
Do you understand? Then I also did the same thing for the variable B. And I said it should also be in a form of an array. But what should it be holding? The same memory addresses as A and its content. Do you understand? So I said let B be equal to the same memory addresses of A and its content. Then later on I came and said I am changing what is in the memory address of memory address B0, okay, to 99, and this is going to have an effect on the original one. So if I should print out what is memory address A0 now, it's going to print out 99 instead of 1 because these ones are dependent. That's what I mean by referencing. But with this one, when I changed the ID to 15, it did not have any effect on the original value of age. Age was still 10. But when I changed the memory address of B, okay, memory address 00 of B to 99 to this, so that let it hold 99, it's going to have effect on the memory address 00 of A also by changing it from its content from 1 to 99 as well. So that's what the code is saying here. So if I should print out what is in the memory address 0 of A, it's going to print out 99. Why isn't it printing out 1? Because they are related. They are all using the same memory address. So if we are all using the same memory address, and then I'm saying that, you can say it's printing out 99. And then I'm saying that we are all using the same memory address. Okay, you were having one in your memory. They are not storing the memory, the content. They are just referencing from memory what is stored in the memory. You understand? They're just going to memory and picking its content. They are not storing anything to themselves. So if you go to memory and what has been stored in memory address 00 is 1, and then I go to the same memory and I said I am changing what has been stored in that place from 00 from 1 to 99. If you should go there again, what will you see? After I have left, if you should go there to see what is there, what will you see? You will see 99 now, because you did not pick values and assign it to yourself. You are just going to the memory address location 00 and go and see what is there and bring it out. I went there at first, and then I saw 1 there and I brought it out. You went there later, saw 1 there and changed the 1 to 99. When I go again, what will I see?
You'll see 99.
I'll see 99. That's what I'm trying to say. They are dependent on each other, based on the fact that they are all just referencing for memory address. So whenever memory address content is altered, they also display the altered one. Do you understand?
Mm-hmm.
But with this one, this guy is dependent. ID is dependent from age. Even though ID went to pick the content of age and assigned it to itself, it's dependent from age. That means that if I should change the value of ID to 15, it will have no effect on what has been stored initially in age because they are not referencing from a memory address. Please, do you understand?
Yeah.
What you might say?
I try and limit
I said,
yourself.
buy that pen. Boy, I mean. Okay, Beneza, thank you. Joshua is like, today your reaction is very low. You are four people. Say him quote no share
Hey,
Charlie.
Josh, no, a master program, like a master was able
Killing share. Okay, so our time is far gone. Okay, I'll end it here because it's like the more I'm talking, the more I'm even confusing people. But the thing to Charlie, it's very easy. Like if you think about it, okay, if you should think about it very closely, it's very, very easy. What I'm trying to say, let me just hit on this one last time. Let's see if everybody will get it. What I'm trying to say is that let's ignore this side and then let's focus on the A and B because now I'm talking about changing the value. Apart this side was just focused on going to that memory address and displaying what is there. Are you okay? But now I'm come to change values, okay, and show that they are dependent on each other. Okay. So let me just comment this guy out. Then let me focus on this one. Okay, what I'm saying is that A has been given a set of values in memory. In memory have addresses and they have been addressed 00, 01, 02, and so forth. So what is being stored inside it? Let me change the values actually so that they don't look like the same 1, 2, and 3 because they kind of like confuse you with memory addresses. Okay, so now let me make them different values. Do you understand? I'm saying that when you go to memory address 00, what are you going to see stored there? 5. Do you all understand that one? When you go to memory address 01, we are going to see that 6 has been placed inside that container. And 02 also hold 8. That's all I'm trying to say. Remember, I am not assigning these values to A. I am not assigning these values to A. I am assigning the memory addresses to A. And then I am assigning these same memory addresses to B. I'm saying that let your memory address that you are holding in A, B, you also hold those same memory addresses. Please, do you understand?
Yes.
Good. Then I say that, okay, B, change the memory addresses you are holding's content 0 from 5 to 99. When A goes to that same memory address 0 to see what is there, is it still going to see 5?
No.
No, it's not going to see 99 because I did not assign these values to A. I assigned addresses. I gave these same two, as I said, if I give two people the same address to a house, you all end up at the same place if you follow that address, right?
Yeah.
So at the end of the day, when you all get there, you are going to see that they are going to see the same color of a building, right?
Mm-hmm.
Good. So if I gave an address to A and I said A have a set of addresses 00, 01, and 02, and this is what has been placed inside them. I gave the same address to B. If both of them go there, aren't they going to see the same thing?
Yeah.
Good. But here lies the case. I said B. When you go to the house, change the gate's color from brown to yellow. When A goes to that same house, is he going to see a brown gate?
No.
No, he's also going to see a yellow gate because when B also went there, B did some alterations there. But A also goes to that same memory address. That is what I mean by referencing. They are interconnected because whenever I change the contents of the address of one is going to affect the other, what the other will also see, because they are all going to the same address to see its content. Do you understand?
Yes, please, I understand.
I hope the understanding has been achieved now, all of us.
Freeman,
Yes, please.
yes. Please. I think this is more practical. learning it like this will be very difficult to recall. So is it possible maybe we'll get a project to work on? Maybe we are creating maybe a simple calculator or something like that. I think when we do such things, we'll be able to recall it
All
quickly.
right. So I will type a question, um, giving instructions on what to do, and then you do it and then submit it in our next meeting. We will share our screens. We are not many. We can share our screens in turns, and then we see what we all came out with. Is that okay?
That'll be fine.
All right. All right. Thank you. All right. So in the absence of any question, I move for the acceptance of the end of the meeting. Anybody who will second me? Seconded by. You can raise your hand to second. Okay.
Again?
Ebenezer, thank you for seconding. Okay, thank you, Vida, for seconding as well. All right, thank you. Let's end the meeting. Have a wonderful evening. And you can DM me. I'm not asleep. You can DM me if you didn't really understand anything. I'll help you out. All right, bye.
Bye.